bread with raisins in it, to be precise. Imagine mixing and kneading dough before placing it in an oven for an hour to bake. In that time, it will double in size and give you a tasty treat. But now, imagine placing yourself on one of the raisins and looking around at the other raisins as the dough rises. A raisin that was initially 1 centimeter away from you will end up 2 centimeters away at the end of the baking time. It will have moved 1 centimeter an hour. If a raisin was already 2 centimeters away from you to begin with, then it will end up 4 centimeters away, moving at an apparent speed of 2 centimeters per hour. A third raisin, initially 3 centimeters away, would finish the bake 6 centimeters distant, apparently moving at 3 centimeters per hour. In other words, the bigger the initial gap between you and the raisin, the faster you'll see it moving away from you. Why? Because the dough is expanding. It's not that the raisins are moving through the dough, nor is more dough somehow being added. Instead, the gap between the raisins is stretched by the existing dough's expansion. The more dough there was between you and a raisin to begin with, the more pronounced the effect of its expansion. And Hubble's law offers up an identical explanation for galaxies. As Slifer realized, most appear to be running away from us, but the galaxies themselves aren't fleeing through space. Instead, the space between the galaxies is expanding and carrying them ever further from us. The more space there was to begin with, in other words, the further a galaxy is from us, the faster it will appear to move away. No new space is being added, merely existing space stretched